Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 1 from the February-March 2023 9709 paper 1 variant 2 from Cambridge. This is a pure mathematics paper, and this question here, we have a line that has equation y equals 3x minus 2k, and a curve which has equation y equals x squared minus kx plus 2, where k is a constant. So we have a straight line and we have a quadratic. Show that the line and the curve meet for all values of k. All right, so if you have a curve, it's a bit too thick, hold on. If you have a curve and you have a straight line, so we have a curve and we have a straight line. There are 3 possible scenarios when you have a curve and a straight line as to their intersection. Either they don't intersect at all, or the line is a tangent to the curve, so you can say they meet at one point only, or alternatively they intersect in 2 points, 2 places. So show that the line and the curve meet for all values of k would be the 2 scenarios that either they meet once or they meet twice, but it wouldn't include them not meeting at all. Okay, so those are the 3 scenarios. I'll keep this here for later. All right. So how do we find when 2 functions intersect? Well, we solve their equations simultaneously. Okay. And the way I like to think about it myself is in terms of substitution, because it makes it like generally clear for all different types of questions. So what I'm going to do is I'm going to take this equation y equals 3x minus 2k, and I'm going to substitute instead of the y in this equation what it's equal to in this equation. So 3x minus 2k takes the place of this y. Alternatively, I could do it the other way around. In fact, I will do it the other way around. I will take the x squared minus kx plus 2 and replace that instead of this y. Okay, I can do either way. I prefer to do this way. Why? Because then I'll have my x squareds on the left and it'll be a bit simpler. So I'm going to replace this y with x squared minus kx plus 2, and I'll end up with x squared minus kx plus 2 equals 3x minus 2k. All right, so now I have an equation. It's a quadratic equation, so I can start trying to solve it by using the zero product property. So I'm going to start by bringing everything onto one side of the equation. So I'm going to subtract 3x, so have minus kx minus 3x, and I'm going to add 2k to both sides, and I end up with this. So subtract 3x and add 2k, this leaves 0 on that side and leaves you with a minus 3x and a plus 2k on that side. Now for me to make this into the form x squared ax squared plus bx plus c equals 0, okay, I know my a is 1, that's fine, but my b is going to be the coefficient of x. Now here you have minus kx minus 3x. I want to combine them into 1. So what I'm going to do is I'm going to take out minus x from the, as a common factor. All right, there's a minus and an x. I'm going to put here k plus 3. Okay, that's going to be minus kx minus 3x. And here I've got my c, which is all of this together, 2 plus 2k equals 0. So that's like the c, and that's like the b. So I'll just write it so it's a bit more familiar. So you have x squared minus, I've got k plus 3 times x plus 2 plus 2k equals 0. So here, this is my a, 1, this is my b, minus k plus 3 is my b, and 2 plus 2k is my c. Now, when you solve a quadratic equation, you have x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. All right, here we're not asked to find any points of intersection or anything like that. We're just asked to show that the curve and the line meet for all values of k. So what we've got to consider here is what's called the discriminant, which is this part here. This is the discriminant because it tells you what discriminates between the number of solutions that a quadratic equation has. If the value of this thing here is positive, you will have 2 solutions. You'll have minus b plus or minus something over 2a. So it'll give you minus b plus something and minus b minus something, two answers. If this thing here is negative, you won't have any solutions because it won't give you any real value. You'll have minus b plus or minus, and this will be undefined. A square root of a negative value will be undefined. So that will be the case. So the first case we looked at when the discriminant was positive will be something like this. Okay, so the b squared minus 4ac is given a symbol like a triangle symbol. That means the discriminant. If the discriminant is greater than 0, you have two solutions, two real solutions. If the discriminant is less than 0, there are no solutions. So the first case, when the discriminant is greater than 0, is like this. Second case, where it's like this, it misses it completely, there's no solutions. The third case would be when the discriminant is equal to 0. Well, if this is equal to 0, you'll have minus b plus or minus 0 over 2a minus b over 2a will only be one solution. It's called a repeated root, one repeated root. And that would be the case where the line is a tangent to the curve. Okay? So what we have to do now is we have to consider the discriminant of this equation and see what values it can possibly take. All right? And then we can decide how many solutions it can have for what values of k and whatever. So I've got to find the discriminant, b squared minus 4ac. And that's going to be equal to, you're going to have minus k plus 3 all squared minus 4 times 1 times c, which is 2 plus 2k. I'm just finding an expression for the discriminant. I'll put this triangle here. I've defined it as that over there. So that's going to be, if you expand this, you're going to have, it's going to be the same as k plus 3 all squared, which would be k squared plus 6k plus 9. Then minus 4 times 2 is minus 8. And minus 4 times minus 2k is minus 8k. So an expression for the discriminant is going to be k squared. 6k minus 8k is minus 2k. 9 minus 8 is plus 1. So the discriminant is given by this expression, k squared minus 2k plus 1. So I've got to think about what are the possible values of this expression. This expression here tells us the values of the discriminant. Okay, this is all the values of the discriminant. So we'll see, you know, what value can the discriminant take. The best way to do it when you have a quadratic kind of expression is to complete the square. All right, you can find the maximum and minimum values of a quadratic, because this will have a minimum value because it's going to be something like this. This is not the original function. This is the discriminant of the function. It tells you the value of the discriminant. So if we were to plot a graph of, this would be the discriminant against k. Okay, so how would that graph look? Well, let's complete the square for this. You have k minus 1 squared. Take away the square of this, which is minus 1 plus 1. So it's a perfect square, actually. So you have k minus 1 squared. So the discriminant is equal to k minus 1 squared. Now, that will be a graph which crosses the k-axis at 1. And it crosses the discriminant axis at 1 as well. When k is 0, the discriminant will be 1. So it's going to look something like this. So the discriminant will look something like this. Okay, so the discriminant will always be above the x-axis. In fact, it will touch the x-axis at this point. Okay, so we can see here that the discriminant is always going to be greater than or equal to 1, or than 0, sorry, than 0. Okay, for all values of k. So the discriminant is greater than or equal to 0. We can say the discriminant is greater than or equal to 0 for all k values. No matter what value of k you put into the original equation, you will always get either two solutions, or in the case when k is equal to 1, you'll get a repeated root where it will be a tangent. So it's for all values. There's never any value of k for which the discriminant value will be negative. So the discriminant is greater than or equal to 0 for all k values. Okay, so therefore we can say that the line and curve will meet for all values of k. Therefore, the line and the curve, okay, will meet for all k values. Okay, either they'll meet once or they'll meet twice. When k is positive, or when k is greater than 1 or negative 1, they will meet twice. When k is equal to 1, they will meet once. There's no value of k for which the discriminant will ever be negative. Okay, so I hope that's clear. All right, one of the students asked me about this. I hope that makes it clear now. So this Very important principle, okay, from the beginning of the course on quadratics. So I hope that was clear. Thank you for watching. Other questions from this particular paper can be found in the playlist that will appear in this part over here. Other questions from the topic of quadratics from P1 of my Cambridge collection can be found over here. Other questions similarly from quadratics of P1 of Edexcel, which questions are very similar, can be found in the playlist over here. There's a lot more questions in that, and you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.